Hi guys, welcome to Module 2, Chapter 9, Geometric Figures by me, Miranda Curtis. Okay, question 1. Question 1, Module 2. Lines L1 and L2 are parallel lines. Determine the measures of angle 1 through angle 12. Okay, first we're going to look at right here, we have 63 and 61. We have to find 7 first. A triangle equals 180. So what we're going to do is 180 minus 63 minus 61 gives us 56. So angle 7 is 56. Oops, sorry. Okay, so we look at angle 1, which is the opposite, and it corresponds with angle 7, and corresponding vertical angles are the same, so it gave us 56. Okay, then we're going to look at angle 2, and angle 2 is the opposite of 63 right here, so vertical angles equal the same, so it's 63. Okay, then we're going to come and we're going to look at vertical angle 3. Vertical angle 3, if you look at the bottom left angle of the triangle right here, it corresponds with 3. And so when they correspond, they equal the same. So that's why it's 61. Okay, angle 4. The angle is the opposite of angle 4 with the value of 61. So right here. So 3 right here is the opposite and has the same value. So therefore 4 is 61 as well. Okay, angle 5 is right there. And angle 5 is the opposite value of 7. So it's 7 is a vertical angle. So therefore it's equal, and it's going to be 56 as well. Okay, now we're going to come over here to angle 6 right there. And angle 6 is a supplementary angle. Supplementary angle means it's got to equal 180. It's a straight line. So right here, we're going to do, for 6, we're going to do 180 minus 61 is 119. That's supplementary. Okay, it's 119. When we have a complementary angle, which equals 90, it has to equal 90. We have a couple of those, but we're really talking about supplementary angles for this angle and the next angle. Okay, so the next angle is angle 8 right here. And so 7 is right there. So we're going to have to do, again, a supplementary angle. And so 180 minus 56 equals 124. And that gives us angle 8. Angle 9, the angle is the opposite of angle 9 is 61. It's right here. So these guys are right there opposite of each other. And so they're going to be a vertical angle and they're going to equal the same. So it's going to be 61. Okay, 10 is right here and 6 is right there. So again, they're just like these two. They're the opposite of each other and they're also vertical. So they're going to have the same one. So 10 is going to be 119. Okay, 11 is over here on the bottom and it is also 11 is the opposite angle of 8, and 8 was 124, and it's a vertical angle, and it's going to equal the same. So it's going to be 124. Okay, and our 12th angle, which is way over here. Okay, 12 is the opposite of 7. And again, they're going to be vertical, and they're the opposite, so they're going to equal the same. So it's going to give us 56. Okay, now we're going to problem 2. Question 2, mod 2. Okay, let line PQ and line AB and RQ and AC. Find the measures of angles 1, 2 through 8. Explain how you found your answer. Okay, so we're going to look over here at our triangle. And to make it easier, you would draw lines to make them parallel lines. But I didn't put that in because I was doing this real quick. but because of angle 1 and angle B and angle C are three angles of triangle, the measurement of 1 can be found first. So this is what we're going to do. We're going to go angle 1 plus angle B plus angle C equals 180 because it's the triangle. All the triangle right here. You got 1, you got 74, and you got 26. So you're going to add that together. It's going to give you 180. Okay, now 26 plus 74 is 100. And you still have angle 1. We're trying to find that. So now we're going to minus 180 minus 100 is 80. And 80 is going to give us 1. Okay, 1 is congruent to angles 3, 5, and 8. Congruent means they're all going to be the same. So 3, 5, and 8 are all 80. Okay, 1 is supplementary to angles 2 and 7. Remember what we said about supplementary in our last question? Supplementary means it has to equal 180. So what we're going to do is angle 2 plus angle 3 equals 180. Okay, so we already found out 3 up here equals 80. So we brought 80 down. And what we're going to do is 180 minus 80 is 100. So angle 2 is 100. And if angle 2 is 100, angle 7 has to be 100 because they're supplementary and they're vertical of one another too. Okay, so angle B, way over here, is congruent to angle 4, which means it's going to be the same. So 4 is going to be 26. Okay, and then C is congruent to angle 6. So we have C, which is 74, and angle 6 is right here. What does congruent mean, guys? Means it's the same. So it's going to be 74. Okay, now we're going to go to question 3. Mod 2. Calculate the measurement of the angles in this concave polygon. Guys, look, before we even go to even further, look at this. This looks scary, doesn't it? It's not. What you're going to do, we're going to start out and we're going to count. See, all these numbers are sides. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 sides, and they want us to find these angles. So for this equation for a polygon is n minus 2 times 180. So we counted our sides. So we already know n is 8. So what we're going to do is 8 minus 2 times 180 is 1080. Okay, now since we already know our outside angles right here, all that is this number, what we're going to do is 3y plus 7y plus 7y plus 7y, we're going to go around the circle, plus 3y plus 12y plus 3y plus 12y, right? Okay, we add that up. 54y equals 1080. So what are we going to do? We're going to go 1080 divided by 54 equals 20. So now we're going to fill it in. It doesn't seem as hard before. Okay, so what we do is we're going to do 3 times 20 is 60. So our little 3y's are 60. Then we're going to fill in 7. So 7 times 20 is 140. All those are 140. And then we have our 12y, and we put 12 times 20 is 240. So that wasn't as hard. It looked scary, didn't it? It wasn't. Okay, now we're going to go to question 4, mod 2. Okay, for the regular n-gon, show to the right, give the measurement of the interior, exterior, and central angles. Okay, it looks scary again, doesn't it? It's not. Remember, guys, we got to count our angles. Okay, measure of the interior angle. And put these up so it'll be easy. So we counted and we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. We have 9 sides. So we're going to fill it in. So for this, it's a little bit different. Not too bad. So it's going to be n minus 2 times 180 over n. So that's not too bad. So we already know what n is, guys. We're going to put 9 minus 2 times 180 over 9. And when you get that, you're going to get 140. So guess what that's going to give you? It's going to give you the interior angle because that's its formula. I should say that. Okay, now we're going to go for the exterior. Okay, so the exterior formula is 360 over n. Guys, remember what n is? N is 9 because we have 9 sides, right? So we'll put 360 over 9, which gives us 40. Okay, guys. And see, since we already know the exterior answer, central angle is the same formula. So we're doing 360 over 9 again, which gives us 40. So we have 40. Wasn't as hard as you thought it was it? No, see, you guys are smart. You got this. Okay, ooh, that looks hard. It's not. Okay, we're going to question 5, module 2. A cube with verticals A, B, C, D, E, G, and H. I'm going to do my little song. Is shown in the accompanying figure. Verticals D, E, G, and H are the verticals of a tetrahedron inscribed inside a cube. Complete A's and B. Okay, before we get into all that, we need to know what a tetrahedron is. And it's a 4-plane triangular face. So that means it just has 4 planes. So A, we're going to do up here. So A is going to trace the cube in one color and draw the tetrahedron D, E, G, H in different. So we got our square up here. Sorry, it's a little squiggly, but it's up there. Okay, so we're going to draw a red line from D to E. Then we're going to draw a red line from E to G. Then we're going to draw a line G to H. And guys, look, we got it. It wasn't that hard. We got it. Okay, now we're going to go to problem B of question 3. It says 3 of the faces of the tetrahedron are subsets of the cube. Find a tetrahedron inscribed in the cube that has none of its faces in the planes of the faces of the cube. So we're going to draw it. You guys ready? Oh, that looked crazy, didn't it? No, it's not. Okay, so we have one line that's drawn from D to F, one line from F to G. We have another line from F to B. We have a line from B to D. Guys, you see all that? Yeah. See, y'all got it. Y'all got it. You're good. You're good. Okay. Now we're going to go to question 4. No, we're on question 6. Okay, we're on question 6. What's up? We're on question 6. Sorry, guys. We've been flying through. I thought this was question 4. Now it's question 6. Okay, draw Schilling's diagram from A, the tetrahedron, B, the octahedron, and C, the octahedron. I'm trying, guys. Promise. Okay, so remember what we said about a tetrahedron. It is 4-plane triangular face. Okay, then we have an octahedron. And an octahedron, octahedron is 3-dimensional shape that have 8 planes. So that one has 8 plane faces and 8 equal triangular faces. Okay, that's not as hard. Okay, then we have an isohedron. Okay, so it's got 20 plane faces, and its triangulars are 1. So A, we're going to show how to do a tetrahedron. We have a triangle. Okay, we have 1 line and 2. Guys, see, that one wasn't really that hard. All it needed, remember, it has 4 planes. 4. Okay, now we have an octahedron. How many faces, guys, remember? It has 8. Okay, so we got a triangle. We got to make 8 faces. 1, 2, 3, 4, 5, 6, 7, 8. See that? Y'all got it. Okay. Now we got an isohedron. Remember, it's got 20 faces. And don't make fun of my drawings. Here's a triangle. Ooh, okay. Look at all those faces. Do you see all those faces? Those are all 20. So when you see this, just think 20 faces. You see the octa. Remember, it's 8. You see the tetra means 4. You got this, guys. You really do. Okay. And I want to thank you guys for watching my module. This is the end, and I can't wait to see you guys for the next module. I hope you joined the little kitty cat. Let's see. y'all.